In this problem, we want to know how much Winston can take as payments in retirement. And so we know that basically this is a two-part problem. We know that Winston's going to be saving. In fact, Winston's going to be saving $50,000 for 5 years, starting in 1 year. And then Winston's going to retire in 5 years. So Winston's going to be paying $50,000 in 1 year, $50,000 in 2 years, $50,000 in 3, 4, and 5 years. And then as soon as Winston pays the last $50,000, he's going to have a certain amount in retirement. And then he's going to be retired and take equal withdrawals for 5 years, with the first payment taking place 1 year after he retires. So the first payment in retirement will be here. That's 1, 2, 3, 4, and 5. So what we need to do to solve this problem is, number one, figure out how much he'll have when he retires. And we can get that as the future value of an annuity. Then when we have that, we want to figure out what the payments are that are associated with that amount. And that's simply the payment associated with the present value of an annuity. We know that he expects to earn 17.2% per year. So the first thing is, let's get the future value of an annuity. And in this case, we know the first payment is in 1 period. There's going to be 5, 1, 2, 3, 4, 5. And then in 5 years is when we want to know how much he'll have. So that fits in nicely with our definition of a future value of an annuity. So in our financial calculator, we're going to want to be in end mode. Set n equal 5. And the calculator interprets this as there's 5 payments. The first one in 1 period, the second in 2, the third in 3, the fourth in 4, and the fifth in 5. And those payments minus negative 50,000. He's going to pay 50 in 1, pay 50 in 2, pay 50 in 3, pay 50 in 4, pay 50 in 5. Present value is equal to 0, PV is equal to 0. There's no initial starting funds that he has in his account. He's not making a special payment initially. The interest rate is 17.2%. That's how much he expects to earn per year. And if we solve for FV, the calculator will tell us what the future value is of 5 payments of 50,000, with the first in 1 year, second in 2, 3, 4, and 5 in 5 years. It's exactly what we want, because that's right when he retires. And he would have, when he retires, roughly $352,000. $352,107.87. So what we know is that he'll have roughly $352,000, and essentially you can think of it as he's buying an investment in retirement that's going to pay him a certain amount, and we can set a retimer, as I call it, retime the timeline. So assume tree time 0 is when he retires. 1 year later he gets a payment, 2 years later he gets another, 3 years later after that, 4 years, and 5 years. And so if you have $352,000, you get 5 equal payments. The present value of these equals the present value of that. We're finding the payment associated with the present value of an annuity. Again, it's an annuity because the first payment is 1 year later after he retires. And that's how much he can expect to get in retirement. So again, we're going to be in end mode because he retires and the first payment's 1 year later. N is equal to 5 because there's 5 payments in retirement. And the fact that they're both N and they both have N equals 5 is nice symmetry, but it doesn't have to be like that. He could be retired for a lot longer than 5 years or even shorter than 5 years. He could start collecting payments immediately, so it doesn't always have to be the same. The payments that we're going to be solving for, PV, how much money does he have? It's as if he puts in the money that he saved for retirement. minus 352, 107, and 87 cents. FV, he's not going to be left with anything when he retires. Or not when he retires, when he's done collecting his 5th retirement payment. When he's done, there's no money left and there's no special payment that's coming to him. So there's no, all there is the regular payments that we're looking at. There's no extra special payment at the end. Interest rate of 17.2%. Solve for payment, and each payment is going to be equal to $110,562.55. So it's interesting is that for 5 years he saves $50,000. Then when he retires, he collects for 5 years, and he's actually able to collect substantially more than $110,000 per year. And again, the key to a problem like this is, in order to know how much he'll collect each year, we have to know how much he retires with. In order to know how much he retires with, we have to compute what the future value is given how much he's saving, for how long, when he starts, and what the rate is.